We're going to talk about Qiling framework, and then there are a few things that we're going to do today. So let me sort out the introduction part. We're gonna introduce a little bit of on a Qiling framework. That's what we're gonna do. That's number one. And then we're gonna show a bit on the demo part, and we're gonna talk about how we work around with how we work together with our R2, and then we're gonna show our very last guest that we promised on the abstract, which is how we can make entire EVM engine more fun. So the topic mainly is going to cover Qiling and R2. So the Twitter is down there. So if you guys have any questions, always hitting to us. The developer sites, the core dev for R2 and us is pretty much friendly. I mean, they came to our chat room and chat, and we go to their place and talk. So yeah, that is what we're gonna do today. And again, my keyboard. All right, the slide is moving. Okay. I work for JD.com. All right. I stationed in China right now, so I cannot say any bad things about the Chinese government, just in case to keep my career and my life going smooth right over here. And most of the time, I'll be doing a Qiling framework. And during the olden days, when conference still a conference, everybody can meet everybody in person. We do design some badge for Hack in the Box. So we have the Singapore ones, you can see the Amsterdam's one, the China ones, and yeah. So this is what I do, and the different talks that I would like to list in the slides. That's everything about me. Introduction for ZiQiao and ChenXu. I will leave it to them. Basically, we work in the same department. We meet each other almost every day, and this is our intimate relationship. So they should have their own introduction. So I'm not going to say a lot of things over here. Okay. Why Qiling framework, and what is the passion within this entire open source project that we get involved into? So when I first stepped into China, one of the first few major tasks that I would like to achieve, as a security consultant in China, it's IoT. And that is back in 2018, 2017. Right. So what I wanted to do over here, it's during the entire time that when we are doing research on IoT, there is a lot of bug that keep on repeating itself, and only exists in. I discovered the same bug and the same exploitation techniques that we can repeating using in IoT, and the same technique and the same bug doesn't really exist in x86 anymore. But the same thing flows back to IoT. And what we are really wanted to do over here, it's we don't have a proper tools, and we don't have the same old experience that we for debugging, for emulation, for instrumentation, or emulation and doing hot patch or different kind of APIs that couldn't bring us to that kind of debugging experience. So what we wanted to do, and what during that time, the only thing was exists in my mind. It's I wanted to bring whatever things that we have in x86, whatever things that we have in the modern days debug, modern days emulation, modern days binary instrumentation. I wanted to bring all this experience goes into IoT and whatever platforms that we can do. So that is the main passion, and that is why I wanted to start a Qiling framework. So when we try to start this entire project, there are a lot of people come over and ask us, they are virtual machines. So they are virtual machines, like QEMU, that you can actually boot up the firmware and run a GNU debugger or whatsoever. And yes, you are able to do that, but there are few things, or there are few platforms that, whatever virtual machine that exists couldn't solve that particular issue. So if you're looking at a master boot record, we don't have anything that allows you to do instrumentation, UFI. You cannot do instrumentation. You can do partial emulations, and you cannot do instrumentation. You can't even really debug the thing properly. And especially smart contracts. Smart contract has been there for so many years, and to do a reverse engineering and debugging smart contract, it's always a big, huge pain. So, and then things like you have all the pin out for all the smaller boards, and then how about if we bump into things like anti debug, or we need to debug a bit lower types of architecture, things like Qualcomm's EDL, that way down to the safe boot mode and all these things. So how we can actually bring all these things and put into one platform that enables to emulate all these platforms, and we can have a overall experience, the same experience that we have in x86, and we're going to bring it into all these kind of little platforms that nobody really cares to build any tools. So that's pretty much Qiling framework. We support all different kinds of CPU architecture, and we are still adding it based on a request from our community, or whatever PR that we have received. And for now, we are able to emulate Windows, DOS, UEFI, Qualcomm EDL. We have things like MBR. Of course, that screen is not MBR, but MBR. Of course, Linux, Mac OS, and we are still working for a few different things. Like we are looking at MCU, we are looking at things like M1 Mac OS, and we try to put in a debugger. So along the way, when we are working on R2 debugger, then we realize that there are more things that we can work together with the core dev team. So that is the main things that we're going to talk today, and the different kind of extensions that we built in built into a Qiling framework. The additional things that we put in is the instrumentation. So the instrumentation, I will not cover it a lot. I mean, we discussed in the previous talk over here in the box and some other conference. So the instrumentation part, we can go into a few levels to cover it briefly. We can go into hardware level, we can go into CPU level, we can go into file level, we can go into memories level. So these are the few instrumentations that we cover, which is quite wide in the sense of how we cover it. Of course, and then the base layer, that will be the entire Qiling framework. Okay, so the features and functionality, again, to cover it briefly, we do a cross-platform, we do a cross-architecture. When I mention about cross-platform and cross-architecture, the definition over here is we are not only emulating x86 32-bit or 34-bit or all the way to ARM 64 MIPS, or different kind of OSs. We always try to make sure when we can emulate that OS, all right, we can emulate the architecture or that OS, we try to make sure Qiling Framework can run on that architecture and OS. Of course, not UEFI and MBR in this specific case, but Windows, Mac OS, Linux, BSD should be able to do the emulation or run on top of the few OSs. All right, and then we support multiple file format for analysis purposes, all the way from PE, ELF, UEFI, or MS-DOS compile. Okay, and the entire emulations and instrumentation, everything, it's in an isolated environment, so it's pretty much a sandbox. And then we designed a series of great API to access to all the different layers, like what I mentioned just now, all the way from a hardware, from a GPU I/O, from all the way to a file system, to CPU, to memory. So you can easily manipulate memory during runtime. All right, you can easily manipulate the CPU register during runtime, or you can easily change whatever file system, the file reading I/O sequence, or what kind of file is your binary reading during runtime. Okay. So, and then, of course, everything, we chose Python. We had a great argument and discussion when we started the project. And the reason why we chose Python, it's very easy for a lot of people to join the project, into the project, and then easier for people to understand the code, easier for people to join into the project, join to the community, to submit PR, to understand how OS works. We even received 1 or 2 feedbacks, from Europe. They actually brings a Qiling framework into the classroom to explain how a OS is working, because we emulate the entire OS, how the OS run binaries and all these things. So these are, I think we built something fun on top of a language that everybody can understand. So try not to ask us why Python again. I think we did a very good explanations over here. So our even goes into the little bit details like profiling, OS profiling support. So basically what does OS profiling support is you can always change your settings within 1 or 2 files, and then it will change the entire environment of your OS, including, language, keyboard type, so for Windows. These are the things that from the community, the antivirus groups or community, they think that, for Qiling to analyze virus, there are some virus detects keyboard and not to run on a specific language keyboard. So, because friends never text friends, right? So they add in these features so they can change the keyboard language on the fly just by changing 1 file, and then they can monitor the behavior for the malware. So of course, later we will look at how we can support Ethereum, how we can support Cardano smart contract, and then ETH 2.0 with WASM. So these are the few things that we're gonna bring into the entire Qiling framework. So there is some similar project. Okay, so a lot of people, when it comes to IoT, they are doing QEMU user mode. All right, some of them is doing a UserCon, but UserCon, they don't really have any update recently, if I'm not mistaken. And then I think in 2018, some group of it was a Carbon Black. I think they come out with a project called Beanie, written in Golang. Not much development ever since after the release. So I'm not too sure whether it's the Golang affecting the project status or what. Okay, I'm not bashing Golang over here, but that's what I'm trying to say. And then we have Wine. Wine is pretty much they only can emulate Windows in a Linux environment, and it's not sandbox. They don't have instrumentation, so it's purely a emulation engine, just like QEMU. Okay, and then FireEye came out with a Speak Easy like 2 years ago, somewhere around last year. So running on Windows, very good project, and I'm not too sure about the development recently. And then Zelos, they are still very active, and I think the only downside is they are not supporting a different kind of OS like what we are planning to do. So that is Zelos. So these few are the very, very similar project that you guys can see. And then most of them, it's not really doing what we are doing right now. And then we try to move further to bring more to bring the same experience into all the different platforms and all the different OSs for reverse engineers. So the entire design, for Qiling Framework, it's a framework, it's not a tool. So we don't have any intention to build a tools. So that is the reason why we received quite a fair bit of our project. Just to name a few over here, they build tools on top of our Qiling Framework. That is what we always intended during the initial design. So Qiling Framework as the base, and then you have all the different tools like EFI Fuzzer, File Insight part of a file insight plugin. Okay, and then this VAC3 emulator. So we always wanted to see all the different kind of project. We even have a generic unpacker. I think we received it like we saw it like a couple of days back that fully runs on a Qiling Framework. So we started to see more project on top of our Qiling Framework, and they brings more value, and the way how they design the tools is actually quite amazing. So we do expect to see more and more different kind of tools that runs on top of the Qiling Framework. Okay. And I mentioned a couple of times of instrumentation, so I guess it's okay, or it's right for me to do the explanation on what is instrumentation, so you guys will have very a better idea on why emulation tools should come with instrumentation and why this is important for reverse engineers. So we have two parts over here, the upper part and the lower part. The upper part, it's where you started to run a binary or smart contract in the sense of our very last session, which is the EVM demo. All right, your file sequence is always starts from A to B to C to D to E to F. All right, so this is how a binary or smart contract should execute. Okay, of course, most of the cases it's not always a one-way flow. They will come back and forth, and you know the entire idea. It's always from start until the very end. Okay, so the instrumentation, the idea for instrumentation is we wanted reverse engineer, all right, to have the same method when they try to execute a binary. If they wanted to change the bytecode or the binary inside the binary code inside a specific file, they can do it on the spot, and then they don't have to execute A. You can start from B, and then you can go to a D, and then you can stop in an E, and then you can start all over again. So along the way, you can replace the function call. You can alter the memory. So these are the few things that few examples that reverse engineer can do. Or even when you design a fuzzer, there are certain places that you want to replace the functions to make sure the executions run faster, or to skip certain functions, so you don't have to run it. You just can return whatever results that you have been expecting. So these are the few things that you can do. Okay, so it comes in very handy for reverse engineers, for whoever wanted to run the fuzzer or whatsoever. So that is a brief introduction for instrumentation. Okay, so I will pass the floor to ZiQiao, all right, and then before he thinks I talk too much.
Okay, so let's start. In this session, I will introduce the story of Qiling and Radar 2. So firstly, the story. So firstly, the story starts with Qiling and Radar. So for a long time, I'm considering the Qiling needs some static analysis. So I found some alternatives. We always use the ADA, but indeed I hate ADA Python. So we found Radar 2, and when Qiling meets Radar 2, I think that is our best choice. So firstly, why Radar 2? Qiling Framework provides almost the best dynamic instrumentation experiences ever since. I think, for example, we have the system emulation, we have flexible hook and snapshot, and we have the full control of our sandbox. For example, you alter syscall, you alter function, you alter the original control flow. So for a very, very long time, I'm thinking of what's next. So firstly, the static analysis, and the second is symbolic execution. Yeah, that is our story today. But the two things are both very complex things. So I think we should stand on the shoulder of giants. But of course, the giants should be free ones. Yes, I have to say again, I hate ADA Python, and you won't see ADA in this session, although they are on my desktop, but I won't use them in this session. So as I said just now, Radar 2 is the best alternative. So why Redire 2? Redire 2, or I say R2. R2 is the Swiss knife of the reverse engineering, but it also has almost the steepest learning curve because it follows Unix philosophy, and the source is your best friend. The dog of the R2 is really bad, to be honest. So you could find almost everything you need for security analysis, for example, disassembly, control flow graph, and debugging. All of those, all the Qiling have some similar functionality, but Redire has more complete one. And there are tons of utilities. For example, the question mark is my favorite. So what we really focus on is the ESIL, or we say Invaluable Strings Intermediate Language. It uses reverse polished notation and is designed for interpretation and suitable for symbolic execution. So for next integration, the story goes to how we integrate the R2 to our Qiling framework. At that time, I was considering integrating R2 to Qiling framework. The R2 pipe was the only available Python bindings, but it requires R2 being installed system-wide. But we always hope Qiling to be installed easily and used by one command, just pip install and you are ready to go. So I don't think R2 is a good choice. So, and also sometimes we will have to call the low level APIs. And another choice is Erlang. Erlang is another way. It runs a Python interpreter in R2. It seems good, but we expect to run standalone. But we wouldn't want to run ourselves in another application, and it also requires full system-wide R2 installation. So I decided to invent the wheel. So here comes R2 libr. First I have to explain what is libr. R2 is split two parts. The bin R, and for example here. For example, we can go to Redire. Okay, as you can see, bin R and libr. It is split two parts. The libr is the core of the R2, provides all the APIs we need. But and also R2 headers is clean enough to do auto generation, so the binding effects are generated automatically with ctypes lib and the GitHub CI. For example, here is an example of our API, and after some auto generation and some dirty hack, in fact, we get Python code like this. So basically, we could have a try here. Installation is very simple. Python 3 or pip install R2 libr, or you can use the argument upgrade. The latest version should be 5.2.1.1, and you can open a Python command line and import the type, import R2. Oh no, import libr, and firstly we create a R core. Then we can execute a command about 7 ? This command will prompt you an Easter egg. For example, what are you doing? So let's do this in Python code. After creating a core, we use R core command string and use the R core just now and create the string buffer and 1 2 3 4 5 7 and encode UTF-8. Yeah, that's it. You get a pointer to a character array. You have to ctypes their dot string at. Oh. Sorry, I forgot. And print. Yes, you get it. So in fact the usage of R2 libr is very verbose since we are using the most low level API, but it can be used to implement R2 pipe in minutes and build many interesting tools. So for next, the story of symbolic execution starts. First now, I have to introduce what is symbolic execution. Although I think some guys may have already been familiar with that. I can introduce in just in 2 lines. In normal cases, you know x equals to 1, then x plus 1 equals to 2. But for symbolic execution, you know x plus 1 equals to 2, then you know x equals to 1, where x is our symbolic value. So it's another way, it's the other way. So and also many symbolic execution framework like Anger, it use an intermediate language. So the essential of an intermediate language lies in it can reduce the large instruction size. For example, x86 size to macro operations, and it's easy to implement and instrument. And the most important is cross architectures. So among many intermediate language, ESIL is a really good choice. The firstly, again and again, is free. It's open source and free and available and easy to interpret. So also I could give you a very short example. For example, so what ESIL looks like. For example, E1. For example, this one. As I said just now, it's reverse Polish notation. So you get 1, 2, and you get a plus. So you get 3, and for example, for a more complex one, for example, 1 REX equals, and you can get REX equals 1, and for example, REX. No. Oh, yes. And 1, 2, with RF equal, and you get 3. No, you get 3. So it's the reverse Polish notation and very easy to implement. So how symbolic execution is implemented in a more generic way? The core concept is state. The state includes a full memory and register at a specific time, and it includes a constraint to reach that state, and it should be immutable. So general style is firstly you input symbolic values and execute and gather constraints and reach some point and solve the constraint and evaluate the same values. For example, on the right figure, for the initial state is state 1 and the constraint is age equals to 1. And there is a if statement, and if AL equals to 0, you get state 2, and if AL doesn't equals to 0, you get state 3. All the 3 states that are not equal, and the AH and AL here may be symbolic values. So when the engine reaches state we would like say state 2 or state 3, we use SAT solver Z3 to evaluate the value of H of AL. And for large and complex algorithms, symbolic execution can really save lots of time. So in this integration with Qiling and Radar 2, what Qiling can really do, the most important part is that we can achieve component reuse. So there are 2 parts. The first part is the system emulation. For example, in a complex function, there are some printf and push. So for this function, Qiling can reuse its syscall emulation, and also for binary load and memory setup. During symbolic execution, you need to set up memory and set up memory mapping and load the symbol, load the data. So all this code can be reused within our existing code base. So our goal is that user can always switch the underlying engine while keeping the high level API unchanged. So also there are some difficulties. In fact, implementation is much more complex than I expected about 2 weeks ago. R2 itself of course implement ESIL, but it doesn't have memory read-write implemented, so we have to do it on. And secondly, we can use R2 register implementation. For example, we can use, for example, REAR this command because as I just said, we have to store symbolic values, and the R2 implementation you can only store integers. So as a result, we did full implementation of ESIL, and it may become another emulation engine to replace Unicorn. And symbolic execution is never a silver bullet. First of all, it's really slow since we have to keep each state immutable, and the state explosion for complex function and makes it almost unacceptable slow. So next we'll show the demo, a simple crack me. First of all, the source is the program source here. As you can see, it's a simple C program, and you get the input from STD standard input and the test input, and the input in fact is it XOR secret with 0x57, and if the result is correct, it returns 1, and if any character is not correct, it returns 0, and the flag is very easy to solve. For example, use testing, and for example we know stack, for example, and we have the bytes, and we can XOR it with 0x57, and we can concat them to bytes. Yes, and the correct flag is Qiling Framework. In fact, we can. Remember this file is a AMD64 file, but again, our framework is cross architecture, so we don't need a real virtual machine since it's the Mac, and we can use QL2 ROM and to test our flag. Yeah, and it's correct. Of course, if you input any other thing, yeah, it will should try again. So next week we can analyze it with R2. So firstly, input R2. There is an Easter egg, and I just if you input enough A, and it will tell an R2 developer is coming to a place to manually analyze this program. Please wait for it. Okay, so just 4 is enough, and we can find our function. What? Sorry, I forget. Okay, we can get our syntax. Sorry, I forget. I can use seek directly. Sorry, I have to restart. I just defined that location with the sim.text. So this time we seek to here and the PD, print the design line. Yeah, that's a function, and R2 has a visual mode, and in this mode we can view the control flow graph. Yeah, what's the shortcut? Sorry, I forget the shortcut. Oh, I remember B. Oops. Go down. So in the graph mode, we can see the real logic. Firstly, in the function entrance, we get the input and we jump to the 0x11D4 and we retrieve 1 byte from the secret and test if it's 0. If it's not 0, it means that the comparison is over and we return 1. And if it's not there, if it's not 0, it goes to this branch and the test input with the secret and test the result. And so basically the most important comparison is here. It's compare CL and AL. This one compare CL and AL here. Double one C5. This one. So we just hook here and when our symbolic execution engine reach this state, we solve the input flag. So next I will show you the code. Where the code? Okay, here. So firstly, this is the file path. For convenient, I hard coded, and you create R2 instance and you open the file. Oh, before Jan, let me run since it's very slow. So during the run, let's see the code. Firstly, just like I did before, we analyze the file and we stick to the target function and we create the engine and like the existing Qiling API, we show map info here. We could show the map info here, and we get our target function and we set the stack and we write the flag. No, there is a symbolic value. We don't know the actual content of the flag, and we write a symbolic value here, and we hook the state there. Here is our callback, and we start emulation. In the callback, we test when it reach 0x C7 here. This jump. And we will add the constraint and we check whether it satisfies these three, and if it satisfies three, and we print the flag, and you can see the result of the script print the flag correctly. So as you can see, all these API is designed like current Qiling API, and they would be put under QR namespace after integration, like QR element rewrite and QR RX and QR command dash map info. And as such, just now all these underlying engines are transparent to the high level users. So for future, in fact, lots of actual code and test case for corner cases needs to be done, especially the memory and register implementation. You know, they are implemented by me, and I'm very, very sure there are still many bugs for them. And I have to rearrange the code to integrate the symbolic execution engine to Qiling code base better. By the way, the codes will be released after some alteration and refactor. And the most important one is that I have to speed up the symbolic execution by optimizing the memory copy. For example, if the state, we can discard the obvious wrong path. For example, some paths it results in the crash, and we discard this branch so it can reduce our search space. Another optimization may be COW, copyright. So there are many things to do. And also we can make contribution to C-type sleep RedR2 during our test and usage, and we can integrate Qiling and R2 in the other way by running Qiling instead R2, like I introduced just now. So last is the credits. First of all, credits R2 for the next project, and the credit C-types lives for R2 libar implementation, and the credit is also for the implementation reference, and Anchor for the design reference, and Z3 for the action server, and lastly, thanks Pancake for the template help. That's all. Thank you.
So today I want to show is another Qiling ability, which is an ETH smart contract NSS. So this time we make a ETH smart contract NSS framework. It's a part of Qiling, and we put it to a new layer, which name is engine layer. That means we can do a serious work on this EVM engine, or we can develop special tools based on this for more targeted direction. Generally, if we want to emulate a smart contract for NSS, we should create both blockchain and host VM. But in our engine, since it will be gonna be very easy, the engine integrate chain and VM. What we need to do is just create a class name EVM emulator, and also changing to any ETH history hard framework hard forks is supported in our engine. The engine provides a lot of functions for NSS, include the smart contract emulator with instrumentation and smart static NSS, dynamic debugger fuzzing, and vulnerability detect, and more. So now I want to show is static NSS function. As you can see, we just create a Qiling class and input a contract bytecode. So it's a string, so we can recover it to bytes. Then we can use NSS bytecode to NSS its structure, and then we can disassembly this to instructions. Then we can NSS function sign. So let's run it now. Oh. So stay to here. Oh, we are in Python. So let's try one. You see, this is full part of this smart contract bytecode, and then we will show the disassembly. Yeah, you see, we can cover the bytecode to instructions. Then we will NSS the function information in this bytecode. We input 3. So here you will see this is the function sign, and we detect the name and the argument of this function, and you can see we found 2 probably function name here. So we must detect deeply, and we will finally we will think this function name is right. So maybe time is out, but there is an example I want to show. This is a reentry vulnerability. So as you see, the attacker will call this pawn, and it will into this withdraw phase. Then it's wrong here. As you see, if we deposit and and withdraw it immediately, it will fail. When it will fail, it will roll back and revert 1 ETH to attacker, and it will jump to this function. Then it will run withdraw phase function again. This is a loop until the balance of this contract is less than 1 ETH. So finally, the attacker will get all ETH in this contract. So we can run this process in our Qiling. So we can close the debugger and re-enter C. Okay, you see. At first, the victim and the attacker both have 100 ETH, and we deploy the DeFi contract, which is the victim contract, and deposit 20 ETH to this contract, and we deploy attack contract. Then we start contract. Finally, we will steal all the ETH in the victim contract, and we make a dynamic debugger. Just open the QL debugger and run. We will try it. Okay. Now we can use debugger, like we can step in and we can disassembly 10 lines. Then we can make a breakpoint at 16. Then just run. We also can check the memory of this virtual machine. Then finally we can run. You see, it will run in a huge loop, and finally it will return, and we got it. So with the debugger and with instrumentation and breakpoint, you can do a condition breakpoint. So this is another store. Okay, so that's all I want to show you today. Okay. So I'm finished.
Your screen, sir. Your screen. All right.
Okay.
So, okay, well, a few more slides before we end. All right. Hopefully we're not taking too much time. And that was the EVM demo. Okay. And like what we say in the slides, I never tell you everything. So we still have more things that we still not yet released. So stay tuned for the code update. So a few more things. Okay. Hopefully we'll be able to release a Unicorn 2 by this year. Hopefully we're going to have a Unicorn version 2 that going to support more CPU instructions and more CPU type. Okay. We also going to do a forward to host implementation. Hopefully this will solve our syscall missing issue. And then of course we're going to support more iPhone, Mac OS, M1 emulation. All right. And then yes, the ETA for smart contracts, first EVN and soon WASM, and you guys already seen the demo just now. So once ZiQiao finish the R2 integration, we also be releasing. So this year it's gonna be another fantastic year for us to do different kind of activities and code release and all the exciting features that we're gonna throw into the community. So always join us. Make pull requests, send us more code so we have more people to work together on the project. Okay. So these are the information about Qiling Framework, our website, our GitHub, our documents, if the documents ever work. Join our Telegram group. Okay, we are always there, and then we are always there to help. All right. And also follow our Twitter. please start our project. That is part of our KPI before we lose our job and we cannot maintain the project anymore. So that's it, ladies and gentlemen. Thank you very much. Thank you for your time.